Hello everyone. In this problem we are going to see how to find the cumulative distribution function CDF of a continuous random variable. Unlike the discrete random variable where we added up just stage by stage, this is going to be entirely a different one. You will have to integrate it stage by stage, which may not be quite as easy as the one which you are seeing for a discrete random variable. But not thinking too hard on it, let us just quickly see what can be done best with the problem. Problem number 1, which says if the density function of a continuous random variable x is given by f of x equal to ax for 0 less than x less than 1 equal to a for 1 less than x less than 2 equal to 3a minus ax for 2 less than x less than 3 and is going to be 0 elsewhere. Then we will have to find the value of a, which is appearing over here in the question, and the second subdivision is to find the cumulative distribution function of the random variable x. We will see what are going to be the concepts applied to get the value of a and the CDF. Recollect the formula. The probability density function PDF has to satisfy two conditions, namely f of x is going to be greater than or equal to 0, and the second condition is that integral from minus infinity to infinity f of dx must add up to 1. So to find the value of a, since the value of a is involved in your f of x, we can make use of the condition that when we integrate it from minus infinity to infinity, f of x dx is 1, and then estimate the value of a. Secondly, for the condition that we want the CDF of x, CDF, which is given by capital F of x, is defined as the probability of the random variable taking the value until the stage x. For a continuous case, we define this as lower limit beginning from minus infinity. And what is this x? X is going to be the upper limit of your probability. So you move till the stage x, the function f of x gets integrated till this point. So your CDF is given by minus infinity to x, f of x dx. Now we will land into the action of finding the value of a. Moving on, write down, we know that minus infinity to infinity f of x dx is equal to 1. This minus infinity to infinity, I am going to now split it into parts. So let me write it as minus infinity to 0, 0 to 1, 1 to 2, 2 to 3, and 3 to infinity f of x dx equal to 1. So how we are doing this? 0 to 1, 1 to 2, 2 to 3. So 0 to 1, 1 to 2, 2 to 3. Apart from it, it is minus infinity to 0 and 3 to infinity. What is the value taken by the function in the remaining portion? Elsewhere, the function is 0. So the function is going to be 0 over here and the function is going to be 0 over here. So this just vanishes. So we are just left out with the remaining functions, namely from 0 to 1 the function is ax dx, integral from 1 to 2 the function is a dx, plus integral from 2 to 3 the function is going to be 3a minus ax dx, and the total sum is 1. Let us start integrating. A is a constant, x on integration is x square divided by 2 between the limit 0 to 1. A is a constant, integral dx on integration is x between the limit 1 to 2. 3a is a constant, dx on integration is x. A is a constant, x on integration is x square divided by 2 between the limits 3 to 2. The total sum is going to be equal to 1. Apply upper limit minus lower limit, a times of 1 by 2 plus a times of upper limit minus lower limit 2 minus 1 plus 3a times of upper limit is going to be 3. So this becomes 9a minus upper limit 3 square a. So this is going to be 9a by 2. So this is your upper limit minus the lower limit. 3 2s are 6a minus 2 square is going to be 4. 4 by 2 makes it as 2a. So this is your upper limit minus lower limit for the third function. This is going to be equal to 1. Now moving on, we have a times of 1 by 2 plus a into, you have 2 minus 1, which is going to be equal to 1, plus this gives me 9a minus 9a by 2. 2 was LCM, 9 2s are 18, 18 minus 9, 18 minus 9 is going to be 9a by 2. Make sure you differentiate your 9 and a. Minus previous line, we have 6a minus 2a, that is going to be 4a. So this is going to be 4a equal to 1. Take the LCM as 2. So when we take LCM as 2, it is a plus 2 plus 9a minus, this is 1 over here. So when we take 2 as LCM, 4 2s are 8a. So this is going to have 2 as base. This is equal to 1. 9, 10, 11, 12. So 12 minus 8a by 2 is 1. So it is 4a by 2 equal to 1. So this is going to be a taking the value half. So when a takes the value half, go and fix it finally for your f of x. So what is going to be our f of x? Fixing the values, ax, so it is going to be x by 2 for 0 less than x less than 1. The next one will be equal to 1 by 2 for 1 less than x less than 2. It is going to be 3 by 2 minus ax. Ax is going to be x by 2 for 2 less than x less than 3, and it is going to be 0 elsewhere. So now we have completed the first task of finding the quantity or the constant a. The second part is to find the CDF. Okay, so the CDF, capital F of x, is given by probability of x less than or equal to x. So it is integral from minus infinity till the upper limit x f of x dx. Again, this has to be done stage by stage. Let us move from stage 1. When we have the limit between the first quantity, which is going to be 0 less than x less than 1. So the integration begins with infinity and it moves till the point x as per the definition, and the function to be integrated. What is going to be the function to be integrated? X by 2. So we are integrating x by 2. X by 2 dx on integration. 1 by 2 is a constant, x on integration, x square by 2 between the limits. So this gives me the lower limit as the value taken over here is going to be 0. So this can be replaced as 0. So we have this as integral from 0 to x. So lower limit is 0, upper limit is x. So apply the value. 2 2s are 4. 1 by 4 times of x takes the value x itself. So it is x square minus 0 square is 0. So it is x square by 4 in the range 0 less than x less than 1. Notice now when we move to region 2. When we move to region 2, this is my F1. F1 I have computed. When I move to region 2 is F1 plus F2. What is going to be F1 plus F2? F1 has been completed for 0 to 1 and F2 has started from 1 and it has to move till the upper limit called as x. So what happens over here? F2 will be integral from 0 to 1 entirely completed for the function x by 2 dx plus, now the second function starts with 1 and it moves till the current value of x. The function to be integrated is half dx. So this is for the range 1 less than x less than 2. So let us integrate it now. X on integration is x square by 2. So that makes it as x square by 4 between 0 to 1, and half on integration is half into x between the limit 1 to x. So this gives us 1 by 4 for the upper limit minus 0 for the lower limit, and when x takes x itself, it is going to be x by 2 minus lower limit is going to be 1 by 2. So x by 2 is the variable over here, and the constant 1 by 4 minus 1 by 2 will give me minus 1 by 4. So the value in the limit 1 less than x less than 2 will be x by 2 minus 1 by 4. So we have completed the second cumulant. When we move to the third cumulant, what happens? So we need f3. f1 is fully done, so we will have to add it entirely between 0 to 1. f2 is fully done, so we add it from 1 to 2. And when you move to f3, it begins with 2 and it moves till the higher value, which is going to be equal to x for the function 3 by 2 minus x by 2. So we make this as f3. f3 is equal to, or the value of f3 will be 0 to 1 x by 2, 1 to 2 1 by 2 dx plus integral from 2 to the point x. The function to be integrated is 3 by 2 minus x by 2 times of dx. So now this gives me x square divided by 4 between 0 to 1, x by 2 between 1 to 2, 3 by 2 x minus x square by 4 between the limit 2 to x. So applying upper limit minus lower limit 1 by 4, 2 minus 1 makes it as 1 by 2. Now upper limit x takes the value x itself. So 3 by 2x minus x square by 4 upper limit minus lower limit, it takes the value 2, 2 cancels off. So 3 minus, now 2 square is going to be 4, 4 will be equal to 1. So this gives me 1 by 4 plus 1 by 2 minus of 3 minus 1 makes it as 2. So this is minus 2 plus 3 by 2x minus x square by 4. So when we take LCM for this constant, so this gives me 1, 4, 4 2s are 8. So that makes it as 5 by 4 with a minus sign. So minus 5 by 4 plus 3 by 2 times of x minus x square by 4. So this is the value of my f3 in the range. What is going to be the range? 2 less than x less than 3. Moving to the last cumulant, this is going to be equal to, so what happens over here? This is fully complete from 0 to 1, fully complete from 1 to 2, fully complete from 2 to 3, and now here it moves as f4. So when we move on over here, so what will be our f4? f4 will be equal to integral from 0 to 1, which is fully complete. For the function, it is going to be equal to x square x by 2 dx, and this now is from 1 to 2 half dx plus integral from 2 to 3, 3 by 2 minus x by 2 times of dx. And for the last case, what will happen? Integral between 3 to x, the function is going to be 0 dx because it is 0 elsewhere. So this moves off, and so you have 1 by 4 between 0 to 1, x by 2 between 1 to 2, 3 by 2 times of x minus x square by 2 2s are 4 between 2 to 3. So now it is 1 by 4 plus 2 minus 1 is 1 by 2, 3 3s are 9 by 2 minus this is going to be 3 square is 9 by 4. Upper limit minus the lower limit is going to be 3 minus 2 square is 4 by 4 is 1. So when we add it up, it's the same as our previous steps, students, but with the constant value. No more of x over here, all the x gets eliminated, and finally we have it as 12 minus 8 by LCM is 4. So that makes it as 4 by 4, and hence the answer is 1, which is going to be the final value of a cumulant. We keep collecting that the cumulant always varies between 0 to 1. So we have reached the end point 1, and hence this forms the cumulative values for your capital F of x. As a consolidation, your capital F of x can be written as, the first value is going to be x squared by 4, 0 less than x less than 1, and it is going to be x by 2 minus 1 by 4 for 1 less than x less than 2. It is going to be 3x by 2 minus x squared by 4 minus 5 by 4 for 2 less than x less than 3, and it is 1 for x greater than 3. That's it, we are done.